Welcome to WSHS Algebra 1 Virtual Tutor. Today's topic is solving linear inequalities. So we have to know what happens with our inequality signs. We shade to the right when we have things like more than or equal to. More than signs look like so, and or equal to have the line underneath them. We use an open dot when it's more than, but a closed dot when we're graphing it when it's or equal to. We shade to the left when we have less than or equal to. Our inequality sign for less than is pointed the opposite direction of more than, and less than or equal to again has that line underneath it. For less than, again, we use an open dot when we're plotting the points. For less than or equal to, we use a closed dot. We solve inequality problems the same as an equation, however, there is one rule. When you multiply or divide by a negative number, you switch the inequality sign around. So if it's more than, it would switch to less than. If it's less than, it'll switch to more than. So for example, we are asked to graph the inequality for letter A. And so what we're going to do is we're going to make our number line. We're going to put 0 right in the middle. We're going to 1, 2, 3 on the right. -1, -2, -3, and -4 on the left. And it says x is less than or equal to -3. So you are making a closed dot at -3, and you are going to shade to the values that are less than -3. Less than -3 would be values like -4, -5, -6, and so on and so forth. So we are going to shade to the left. Now letter B is a little trickier because we have x's on the opposite side. So the first thing we have to do is we have to switch it around. So what you need to do is when you read this, you want to read it backwards. So you want to start with the x first always. So if I start and reading this from right to left, this reads x is less than 5. Now that I've switched it using my symmetric property, I'm now going to graph it on my number line. I'm going to put 5 right dab in the middle, 6, 7 on either side, 4 on the left, 3, and 2. We have x is less than 5, so we're going to use an open dot, and we are going to shade to the left because we want numbers that are less than 5. And numbers like 2, 3, and 4 are less than 5. Then letter C, we have the same idea. We have y is greater than 0. So I'm going to make my number line. We have 0 right dab in the middle, 1, 2 on the right, -1, -2 on the left. And we want is greater than. It's greater than, so I'm going to use an open dot rather than a closed dot. And I'm going to shade to the right. So I want numbers greater than 0. So that's how we graph inequalities on a number line. Now example 2 is actually solving for the inequality. And it's asking us to graph it on a number line as well. So we solve inequalities the same way we solve equations. We have to clear the fraction, use the distributive property, combine like terms, letters on the left, numbers on the right, and then divide. So we have a fraction, so that means we have to clear the fraction. So we're going to multiply both sides by the denominator, which is -8. When I do that, I multiplied by a negative number, so I need to flip my inequality sign to make it a less than now. -8 times 3 will give me -24 on the left, and on the right, your -8 cancels, so we're left with -8 plus b. Now we're going to solve for b. In order to get b by itself, we have this -8 stopping it, so we have to add 8 to both sides. -24 plus 8 is going to give us negative 16 is less than b. Now, to rewrite this, because we want the letter on the left, we're just going to flip everything around. So b, and remember we're reading it backwards, so b is greater than 16. So when I go to graph this on my number line, I'm going to put 16 right in the middle, 17 on the right, and 18 on the right, and 15 on the left, and 14 on the left. I'm going to make an open dot, and I'm going to shade to the right because I want numbers that are bigger than 16. Letter B. Again, I'm going to draw a line down my inequality sign. I have nothing to clear the fraction for, but I am going to distribute negative 4 and negative 4 again to the other sets of parentheses. So I have 72 is less than or equal to negative 8x plus 4 minus 12x plus 8. Next is combining like terms. Negative 8x goes with negative 12x. Together they make negative 20x. And 4 goes with 8, and together they make positive 12. So we get 72 is less than or equal to negative 20x plus 12. Now we are going to subtract 12 from both sides. And when we do that, we get 60 is less than or equal to negative 20x. And we have to divide each side by negative 20 to get x by itself. I divided by a negative number, so I flip my inequality sign. And I end up getting negative 3 is greater than or equal to x. But because we want the letter on the left, we flip everything around. X is less than or equal to negative 3. So here's our answer, and now we have to graph it on our number line. So I have negative 3 right in the middle, negative 2's on the right, negative 1's on the right, negative 4's on the left, negative 5's on the left. We have or equal to, so that means I'm going to make a closed dot, and it's less than, so I shade to the left. Less than left. Okay, they both start with L's. Letter C, same idea. We're still trying to solve for the variable, just like you've done with solving equations. We are going to distribute negative 4 to the parentheses and negative 2 to your parentheses. Negative 4x plus 32 is greater than or equal to negative 4x plus 32. Letters left, so add 4x to both sides. And if you notice, negative 4x plus 4x is 0, so we get 0 plus 32 is greater than or equal to 0 plus 32. 0 plus 32 is 32 is greater than or equal to 32. Now, is this a true statement? Is 32 greater than or equal to 32? It is true. So because this is true, your answer is infinite solutions. If it was false, it would be no solution. So when you go to graph this on your number line, you actually end up graphing, you can graph 32, but you're going to color in your whole number line because any number would work here. Now for letter D. Again, same idea. We are solving for x. Distribute negative 2 to 8 and negative 3x to give us negative 16 plus 6x is greater than 6x plus 2. Letters on the left, so minus 6x to both sides. Cancel, cancel. We get negative 16 is greater than 2. Is this true? No. So your answer is no solution. Negative 16 will never be greater than 2. And then you do not have to graph it. So if we look at our practice problems, we'll work through these 4. Again, you want to distribute negative 5, so we get 100 is less than Negative 5 plus 35m. We're solving for m, so we want to add 5 to both sides. So you get 105 is less than 35m. And then you want to divide each side by 35 to get m by itself. 105 divided by 35 will give you 3. So we get 3 is less than m. But remember, we want the m on the left, I'm sorry, so that m and it's greater than, so m is greater than 3 would be your solution. And to graph this on your number line, you'd put 3 right in the middle, 4 on the right, 2 on the left. M is greater than, so we want an open dot, and we want to go towards the 4, so we want to shade greater. Number 2, we're going to start by distributing negative 5 to give us negative 300 minus 2k, negative 300 plus 10k, less than or equal to. Add 2k to both sides. Negative 300 plus 12k is less than or equal to negative 300. And we're going to add 300 to both sides now. And we get 12k is less than or equal to 0. And now we still have to get k by itself, so we divide both sides by 12. And we get k is less than or equal to 0. Just because you get 0 on the right side does not mean that that's not your solution. The only problem that works, 0 and k has to be anything that's less than 0 are your solutions. So if we go 0, 1 on the right, negative 1 on the left, negative 2, this is going to be a closed dot at 0 and shaded to your left. Number 3, we're going to distribute negative 3 to the parentheses. That gives us negative 15v minus 24 plus 2v and negative 102. You want to combine like terms, negative 15v plus 2v, and that's going to give us negative 13v minus 24, less than or equal to negative 102 on the left. You want to add 24 to both sides. And when we add 24, we get negative 102 plus 24. And that gives us negative 78 is less than or equal to negative 13v. Now to get v by itself, we divide each side by negative 13. And that gives us 6. But remember, we have to switch our inequality sign because we divided by a negative number. And we get 6 is greater than or equal to v. But again, we need that variable on the left. So we say v, read it backwards, is less than or equal to 6. When I go to graph this on the number line, 6 is right dab in the middle, 7 on the right, 5 on the left. We want a closed dot at 6. And we want to shade to the left because we want less than. Okay, so biggest thing here is you remember to flip your inequality sign when you divide by a negative number. Let's look at number 4. You have to distribute 7 on the left, and you have to distribute the 4 on the right. So we get 7 plus 14m is greater than or equal to 3m minus 20m minus 24. We want to combine like terms on the right side. So we get negative 17m minus 24 greater than or equal to 7 plus 14m. You want to add 17m to both sides. And we get 7 plus 31m is greater than or equal to negative 24. Subtract 7 on both sides. 31m is greater than or equal to negative 31. Divide both sides by 31. And we get m is greater than or equal to negative 1. Now from here, we have to graph this on our number line. Negative 1's in the middle, 0's on the right, negative 2's on the left. We want a closed dot, and it's greater than or equal to, so we're moving to the right, shading to the right. And that wraps up inequalities. So please take the time to do the practice problems at this time.